Well, good day to you all. My name is Jerry Sansoni. Having worked in the manufacturing industry since the early 1980s, I wound up starting my CNC career in a small job shop on the northwest side of Chicago. That first shop became my home for just over 24 years when the opportunity to work at LG Evans came about. Being able to take my real world experience and combine it with the technical resources available to me now has put me in a very enviable position to continue doing what I love, solving problems and making things work. When we start to think about writing a program to machine a part, we're essentially deciding on a process that will bring the tools in our machine to come in whatever configuration is possible to make that part in the most efficient, economical way. Your Citizen machine is here to help, and that's with the special G600 codes. As we look at parts that seem to get more complicated with each passing day, I'd like to talk about some programming code in the Cincom world that lets us simplify an outrageously complex set of machine movements and configurations. Depending on how you want to bring your needed tools into a cut to maximize all the capability your machine offers, the G600 codes will give you the control you need in an easy to see and use group of special commands. We'll see how these commands control simultaneous, superimposed, and synchronized machining in your shop on your machines. Let's take a closer look. We all know and love our Citizen machines, from our basic 2-channel A-platform lathe to our top-of-the-line L32 Type 12, to our most complex 3-channel 13-axis machining center, the M32 Type 8. How do we translate that kind of capability into a manageable solution? When we're ready to start using those axis groups to machine our parts, Citizen Cincom has the answer with the G600s for their control. As these machine shots show us, we have a myriad of tools and axis groups to choose from to make our part in the fastest, most efficient way we can. Let's look at how the G600s help us do that. Our first example is the G610 for the M platform. I'd like to say as we go along, we're going to separate our M and L platforms for clarity's sake. The programming is technically the same, there's just more of it for the M machine. Now getting back to that M, as you can see in the two drawings on the left, when the control reads a G610, the turret instantly comes all the way forward to a fixed position to complement the gang tool post to machine the front side, while the subspindle works on the back tool post. We have two configurations. Top shows G611 with the gang as the active post, and the lower drawing shows G612 with the turret now active. Looking at some actual program code, in the top screenshot of this program, the G612 puts the turret tool as the active cutter. The lower shot shows with only a G611, the machining transfers to the gang tool post. Even though in the machine world, the turret is X2 and the gang is X1, in the G610 world, there's only one X, the one for your part. We also see how the G610 goes across all three channels and acts as a wait code to move to the next machining mode change. While the G610 for the L machine, the opposite tool post comes forward to machine on the front side. We are sometimes limited on the size of a face drill or boring tool in the gang tool post. By putting these tools on the opposite tool post, the G610 helps us tailor our machine to our needs. The process pictured on the left shows the two G610 codes in place. In the first channel, or $1, the 610 is immediately followed by machining code to continue making your part. In the second channel, or $2 on the right side, the program sits on the next 600 code and waits until all the machining with these tools is complete. Looking at this video, we see that getting these three face tools in the gang tool post would have required a completely different setup with holders that may not have accommodated these size tools. Installed in the opposite tool post, it's no problem. Although the drill, the bore, and the thread mill that we see here are again on the machine Z2 axis, our program is on the main side and our X is just X, Z is just Z, and our Z0 is the face of the part. When the next G600 is reached, in this example it's a G630, the subspindle goes home and the machining continues. We see pull out, there it goes back to front and back. Our next G600 code is the G620 for the M platform. This code superimposes now the turret Z, Z2 onto the part Z or Z1 axis. Unlike the G610, the turret now moves independently of the Z1 axis, but always relative to it. This way we can combine a gang tool and a turret tool to work on the part together. One strong example is to bring a drill in on center to drill the face, while the gang turns the OD, saving us the time of one entire operation. Also, as shown in our layout drawing, the sub is still busy working on that back side. What do we do when we're faced with a large diameter bar with more than one roughing pass to get down to a particular diameter? With G620, we use the gang tool, in this program example, tool 2, as the rougher, and independently program the turret to turn the profile finish with tool 27. The two lines of code circled in red show the queuing command to tell the finish tool when to come in. Again, there's only one X, one Z, and one part. As we watch the video, what's most interesting to see is how, when the turret tool backs off out of the cut to allow the gang tool to cut the thread, watch how the turret tool then follows Z0, or the face of the part, back and forth before coming back in to finish the profile. I can't even imagine how long it would take me to program those tool movements as separate systems. The G620 brings those systems together, working as one on your part. Now the G620 for the L works the same way, but instead of the turret Z2, of which there isn't one, the opposite tool post Z2 gets superimposed onto the main Z1 axis. Z2 is independently programmed, but always working relative to the face of the part on the main side. G620, a while back, I had a part that needed an extremely unique solution to be able to machine it. Working along with the customer's engineer, we came up with the idea to support small tubing with a pin barely undersized from the tube's ID to be inserted into the tubing while we machine the OD. We're having a lot of trouble with runout and felt the pin that this might help. Now, to program this pin in two separate coordinate systems, to come in on the fly, stop at a specific Z position, and then follow all the while the gang machined the tubing would have been nearly impossible. By using the G620, the pin was instantly superimposed to the face of my tube. I just programmed the movements to my part. The highlighted lines you see ending with L9 are the weight codes that controlled when the pin started to move. After the pin rapids to 1 inch away from the face, the code calls the pin to eventually stop at 1 inch into the part. There's no Z1 or Z2 here, it's just Z. The pin stays at 1 inch while the gang tool turns the part. How this would look to the operator is the subspindle would be moving backwards as the tool came out of the guide bushing, keeping that pin at its 1 inch mark. There's a second weight code in the second channel, highlighted by a smaller arrow ending in L99. When the program in $1 hits the same code, the subspindle rapids to ½ inch away from the face, then all the way back. Our next G600 is a G630 for M. Like the G610 before it, the G630 gets split into two, namely 632 and 633. Let's see how that works. Overall, G630 is parallel or simultaneous front and back machining. This is the bread and butter code of the Citizen machine. It allows us to separate machining of complex parts to front half and back half, and then machine both halves at the same time. Your resulting cycle time is whatever is the longer half. On the M, as we separate front and back, we're given even more options on the back side. With the G630 followed by a G632 in $2 and $3, the gang tool post machines the front side, while back machining is taken care of by the turret tool post. Programming is in the center channel, and the turret is instantly active relative to the back face of the part. I'd like to also point out the I arguments after the G632s in $3. This argument allows us to shift the fixed position of our subspindle Z3 when needed, for example, for a deep hole drilling operation. Now with a G630 followed by G633, the back tool post becomes the active one for machining. Although your G630 goes across all three channels in your M machine, we focus on channel 2 and 3 to see that with the G633, after the 630, all programming shifts to the last channel for the back tool post to now be instantly active relative to the back face of the part. In the queuing box shown here, all operations highlighted with the yellow downstroke are completed before the machine sees the next G632 to shift back. G630 is defined the same when moving to our LNA platforms. This time, however, there's only one tool post for the front, the gang, and one for the back tool post. As seen in this screenshot of some 2-channel code, it's just G630. The front begins machining with tool 12, in this case a boring bar, while on the back side, an M98H1 subprogram sends the control to a subprogram which directs the back machining. In the queuing window, we see the operations with an S in front showing us machining with tools 31 and 33 on the back tool post. We like using subprograms on the back side of parts because of Citizen's proprietary last part program capabilities. This way, we don't have to write out the back machining code twice, even though we use it twice. First to machine the backside and the continuous running of the part, and then when we access it again after cutoff in one cycle, to finish the backside without starting another part. The last G600 code we'll look at today is the G650. This code is the command to change the mode of our machine to superimpose the sub spindle onto our Z1 axis on the front or main side, whether it's the sub in an M, a Z3, or an L or A Z2. The face of the sub spindle is the Z0 reference for the back side, and the machine instantly knows where that face is relative to your front as soon as the control reads the G650. As shown in this M program example, the G650 is across all three channels of code. In the first channel, after a wait code, to make sure we're ready, tool number 1 cuts off the part. In the second channel, we just wait for the main and back sides to complete. In the third channel of code, we see the G650 with a W0 argument placed there to keep the sub spindle where it is when the call to instantly superimpose is made. The sub gets fed to its cutoff position on the part, the control reads the queuing wait code, and the cutoff is completed. When we look at the L program example, it's almost exactly the same as the M without the middle $2 channel. The W0 argument was used again because the sub was already on the part supporting it, and I didn't want it to go back to home pulling off the part and then come right back on. In the video, we see the sub spindle come into a position on the part that is extremely close to the cutoff tool. With the left-handed cutoff tool, as shown here, I've come as close as 5/1000ths of an inch away from the cutoff and never touched once. In these next 3 videos, we're going to see they're all of the same part in the actual machining order that they occurred. In the first, the sub spindle is synchronized to the main spindle exactly before the G650 superimposition. Once the sync is complete, the sub comes into its programmed spot, the collet closes while the part turns, and the sub is now supporting the part as machining continues. If this were on an M machine, we would have the added bonus and power to program a G620 after the 650 and bring a turret tool into the cut at the same time, still only working with that same 1X, 1Z, and 1 part. As the part gets machined further in Z, the amount of whipping that would have occurred is completely eliminated from the operation. We can utilize the full stroke of the Z1 axis while we support the part in the cut. Looking at our second video here, the sub spindle collet never opened as the gang transitioned to a milling operation. Once the spindles are synchronized, they stay that way from turning through C-axis work and back to turning. Looking at the center video, we see a small inset with the milling animation. All of the code for this part was generated using Esprit CAD/CAM software. The insert shows a simulation of the machining that you can expect to see when you start to cut chips. As shown in this video, the similarity is uncanny. Now looking into that last video, as the machine finishes up with the milling, we see the cutoff tool come into position. The sub spindle collet opens, the sub feeds further onto the part to its programmed position, and the cutoff is complete. Seamless movements for your critical to quality finished parts that will meet yours and your customers' needs first time and every time. As we move forward in our attempts to make the best parts possible for our customers, we know we have these G600 modes at our disposal to use as the powerful tools that they are. Instead of complicated macro programs or lines and lines of endless code to connect one axis group with another in the machine, Citizen gives us a group of simple codes to tie it all together. From supporting the part to getting multiple tools in cut at the same time, to regripping or taking the part at cutoff, there's just one X reference, one Z reference, and that's your one part reference. The machine can take it from there. Thanks for your time, and you have a great day.